Good morning, everyone. Now, today I'm going to explain application of Coulomb inverse square law. Inverse square law. Now, you see, yesterday I explained charge Q is at this corner. This is another charge. I'm taking the charges. Charges are placed at corners of polygon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 polygon. And next, distance from here to here is L. I'm taking. This is a distance between charges. Now, from here to here is a distance is this is root 3L. From here to here is a distance is this is 2L. From here to here is this is a distance between two charges is root 3L. Now, net force acting on a charge. This is Q is at this corner. We take this is a Q. This place is Q. So what is the net resultant force or resultant force is acting on this Q? Now you see here, this is a positive charge. This is a positive charge, and the remaining charges and 1, 2, 3, 4. These 4 charges are rest position. Now Q and Q, these 2 charges are present. This Q will repel to this Q, this direction, that is a force F I'm writing. Now, Coulomb's inverse square law applies between the 2 charges. Now, that is a F1 is equal to 1 by 4 pi epsilon naught, I'm taking K, and Q into Q squared, distance between 2 charges is L squared, that is a F1. Now, next. This Q and this Q both are activated, and Q this charge 1, 2, 3, 4. 4 charges are absent. Remaining 2 charges are present. That Q and Q both are present. Now, and this Q will repel to this Q this direction. This direction, that is F2 I am checking. Now Coulomb's inverse square applies between the 2 charges. That is F2 is equal to K into Q squared. Distance between the 2 charges is root 3L whole squared. Now you can write this is F2 is equal to K into Q squared by 3L squared. That is F2. Now next F3. This Q will repel to this Q this direction. That is remaining charges are all are absent. All are absent. That is F3. F3 is equal to K into Q squared. Distance between 2 charges is 2L whole squared is equal to F3 is equal to K into Q squared by 4L squared. 4L squared I'm writing 4L squared. Now next this Q, this is a positive charge, this is also positive charge. Remaining all charges are absent. Q and Q both are activated. This Q will repel to this Q is this direction. This is a force I'm checking. This is a F4 force. Now F4 force is equal to K into Q squared by root 3L whole squared. Now you can write this is F4 is equal to K into Q squared by 3L squared. That is F4. Now this is a Q and this is also Q. Both are this Q. This is a Q charge. This charge will repel to the charges this direction. That is a F5 force. F5 force. Resultant force is acting on charge Q. That is a question mark. That is a question mark. Now, so Coulomb's inverse square law applies between the charge F5 is equal to K into Q squared by distance between charges L squared. L squared. That is a F5 charge. F5 charges. Now you are seeing to the figure. Now you see here carefully, and F1 this is F1 force. F1 force. You see, this is a F5 force. F5 force. F5 force. But angle between the two forces is 120 degrees. 120 degrees. Now you see the resultant force. Resultant force is equal to F15 is equal to, you are getting, this is a force, F force. Now you will see the F1 force, F1 fires, and two charges between the, you see F5 force, F1 fire. This is a F1 force, this is a F1 fire. F1, F5 fire. What is a F force? You are seeing, you are getting F is equal to K into Q squared by L squared. This is a value is F1. F1 fire. Now, so next another force. Now you see the resultant force. Now our force is F15 force is along the F3 direction. F3 direction. F3 direction. Now you will see the F15 along F3 force. F3 force. Now, so resultant force is equal to, now okay, that is a conclusion. First point. Next another point. You see the F2 and F4. This is a F2 force. This is a F4 force. Angle between the two forces is 60 degrees. 60 degrees. You see the F2, F4. F2 and F4 resultant. Now, the resultant force is equal to F24 is equal to root 3F. Root 3F. Root 3F means you can write F24 is equal to root 3. F means F2 or F2 or F4. You can write K into Q squared by 3L squared. 3L squared I'm going to write. Now, this is F24 is also along which direction? F24 also resultant force is along F3 force. Now, so finally, okay. So finally, conclusion is your force is you see, so F2 force plus F3 both are same direction, both are same direction. Now you'll see both are same direction. Now you see the same direction. Now you will take F15 plus F3. You are getting resultant force. Actually, the thing is, how many forces are along the same direction? This is a F3 force. This is a F2 force. This is a F2 fire. Three forces along the same direction. The resultant force is we have to add the resultant force. We have to find out the resultant force. Fr is equal to F25 plus F24 plus F3. You are getting this. Now you'll see the, so first of all we have to calculate F24 plus F3. Otherwise you can take F15 plus F3, same direction. F15 means what is the K Q squared by L squared plus F3 means what is the F3? K Q squared by 4L squared. Now you are getting answer is K Q squared by L squared. Take the common 1 plus 1 by 4. Now K Q squared by L squared, 4 plus 1, 5 by 4 your answer. Now, so finally, what do you want? F4 is equal to resultant force is equal to, this is F15 plus F3 plus, now you can add F25. Now finally what we are getting, finally what we are getting, now you see that now you see that one. So F4 is equal to F15 plus F3 plus F25. Now this answer is K Q squared by L squared 5 by 4 plus F25. F25 means 1 5 is along 2 4. 2 4 is along 2 4 F3. 2 5. 2 5 in the F1 5. Sorry, this is a 1 5 more. 1 5. 1 5. 1 5. And the next 2 4. This is a 2 4. 2 4. 2 4. This is a 2 4. Okay. Now, F2 4. F2 4 means, where is that equation? 2 4. 2 4 equation is this one. Now, you can add. This is, you can write this equation F24. F24 is equal to root 3 KQ squared by 3. You can write root 3 into root 3 L square. Root 3 cancel each other. Now you can write K Q squared by root 3 L square. Root 3 L square. Now take the command KQ squared by L square. 5 by 4 plus now 1 by root 3, your answer. This is a resultant force. Your answer is resultant force is equal to KQ squared by L squared into 5 by 4 plus 1 by root 3. 5 by 4 plus 1 by root 3, your answer. This is your answer. Okay. This is over. Now you'll see this is a polygon. Chart displaces Q. This is a Q. This is a charges Q, Q, and Q here, Q answer. Now you'll see charge is placed at this point. Now we have to find out resultant force. Resultant force acting on centroid. Centroid. Resultant force is acting on centroid. Now we'll see distance between here to here is the same distance. You can take this is a equilateral triangles. Equilateral triangles. This is all equilateral triangles. Now you will see this Q. This is a Q charge. The charge repel to the charge is this direction, that is F force. Now the charge will repel to the charges downward direction, that is F. Now the charge is repel to the charges this direction. The charge repel to this direction, that is F. The charge will repel to the charges this direction. The charge repel to this direction F. Now you will see all are same direction. Resultant force is net resultant force is equal to 0. Your answer. Resultant force is equal to 0. Next, second question. Next, second question. Now we'll see. This is one more polygon. Minus Q plus Q minus Q and Q. and this is a Q charge. Okay, resultant force acting on centroid. Resultant force is acting on centroid. You will see this is minus Q. This minus Q. This is a plus charge. Minus Q charge will attract this Q is a downward direction, that is a F force. F force. Now this is a minus Q. This is a plus charge. This minus Q will attract this positive charges this direction, towards that direction. Remaining all charges are opposite. This minus Q will attract this positive charges towards this direction. Remaining charges are opposite. Now this is a positive charge. This is also positive charge. This positive charge will repel to this charges downward direction, that is a F force. Now you see this is a positive charge. This positive charge will repel to this Q charges downward direction, that is a F force. Now this is one more positive charge. Remaining all charges are absent. Only this charges are present. This positive charge will repel to this positive charges this direction, that is a force is F force. Now you will see what will happen in this situation. You will see, take out this one. This is a resultant force is F plus F. This is a 2F. Now this is a downward direction force. F plus F, both are downward direction. Both we have to add to F. This is a one more force. What is a force here? This is a F plus F, both are same direction. We have to add. Now you will see an angle between these two forces, 2F and 2F. Angle between the 2F and 2F is angle is here 120 degrees angle, 120 degrees. You will see 120 degrees angles. Now we know very well this is a 120 degrees angle means you will see that this angle 2F, this is 120 degrees means this is 2F means resultant force is equal to 2F. Resultant force is equal to 2F. You will see, already I told you very clearly in previous classes, resultant force is equal to 2F. Now, this 2F is which direction? This direction. The resultant force is this direction. Now, you will see the this is a resultant force is equal to 2F. So finally, this is a 2F resultant force. How many forces are along this direction? Resultant to this is a force F1. I am taking this is a F2. This is a force is F12 is equal to 2F. Now this is I am taking F12. This is a F1 force. This is a F2 force. Now you can write F1, F2. Resultant force is F12 is equal to F along this direction. Now this line having two forces along this direction. Resultant force is equal to 2F plus F12. 2F plus F12 means 2F. Now finally 4F your answer. 4F your answer. What else? All right. Now we'll take the second question. In second question, this is a polygon. And Q, here Q, here Q, here Q, here Q. Distance between length is L length. Length is L length. Do you know this one? Equilateral triangles. All are equilateral triangles. This is a distance. Distance between the charges is distance between charges is L length. Now we will see this is a Q. This Q will repel to the charges this direction, that is F. Now the charge also, the charge will repel to the charges this direction. Both are in opposite directions. Now you'll see this is a charge. This charge, positive charge will repel to this positive charges downward direction, that is F. This is a positive charge. This positive charge will repel to the charges upward direction, that is of course F. Okay, now this is a positive charge. Length I am giving, you are confusing. Length of this all are L. Keep in your mind the points. Okay, you will see clearly. Now this is a charge. This positive charge will repel to the charges this direction, that is a Q. Now we will see this force cancel each other. This force cancel. Now this is a force is downward direction. This force is upward direction. Both are equal in opposite direction. Cancel each other. This is a force is towards this direction. This is a force is towards this direction. Both are equal forces but in opposite direction. Cancel each other. Now only two forces. Now length is L. Q and Q. Apply the Coulomb's law. F resultant force acting on the charge Q is equal to K. Q into Q. Q squared. Distance between two charges is L. L squared. Your answer. Your answer is L squared. Now next cube. Next cube mark. This is a cube. Charges placed at all corners of the cube. Charges are placing each corner of the cube, and this is centroid. This is charge is cube. The resultant force is resultant force are acting on Q. This is a Q naught. You think Q naught? So what is the answer? Resultant force is, your answer is 0. Now next I'm going to explain the next answer. Next I'm going to explain the next answer. Next question. This is a cube. This is a small charge cube. This is a capital Q. This is a line. Distance between the two charges is R, and distance between the two charges is R. So Q is small q value. What is a small q value? So that the force on Q, capital Q is 0. Your question is that one. This is a question mark. So what is a small value? So that the force on Q is 0. Q is equal to 0. You'll see that this is a positive charge. This is also positive charge. This is one more positive charge. Now we have 3 positive charges. Okay, this positive charge is acting on the charge. What will happen in this situation? This Q will repel to the charge. Which direction? Which direction? Now, you see, this is a force is acting on the charge. This Q will repel to this charges. Which direction? This direction. That is a force F. Now apply the Coulomb's law. F1 is equal to Q into capital Q small q by distance is R squared. That is F. Now you can take this Q is acting on the charge. This is a Q is acting on this direction. This is positive charge. This is another positive charge. This positive charge will repel to the charges this direction. There is a force F2. Yep. Now Coulomb's law, according to Coulomb's law, medium between the two charges is Q. Distance between the two charges is r plus r2r. Now capital Q squared, Q into Q squared by distance between the two charges is 2r whole squared. Now F2 is equal to K capital Q squared by 4r squared. That is the F2 forces. Now two forces are along the same direction. The resultant force is equal to F1 plus F2. F1 plus F2. F1 plus F2. Now we will see the capital Q is equal to 0. Resultant force is equal to, I'm taking 0. This is a F1 plus F2. Now take any force this direction. F1 is equal to minus F2. Now you can take minus this side. Okay, minus F1, take this side. Now you can take minus F2. Okay, you see the F1 force. What is the F1 force? K into capital Q small q by r square is equal to minus F2 means K capital Q square by 4r square. 4r square. K cancel each other, r square cancel each other, capital Q and 1q cancel it, the remaining 1q there. Small q is equal to minus capital Q by 4. Your answer is this one. The system is in equilibrium situation. The system is in equilibrium situation. Now we have to check it. It is whether it is correct or wrong. How can you correct this one? How can you check it? F1 plus resultant force is equal to F1 plus F2. Now F1 means what is the value of 1? K. Check the answer. Check. And F1 means K Q by R square plus F2 means K Q square by 4R square. This is a resultant force. Resultant force is equal to K capital Q, small q means in the small q by R square. Small q means minus capital Q by 4 plus K square 4R square. Now we can write resultant force is equal to capital K, this is a Q into Q square minus by 4 into R square plus K Q square by 4R square. This is a plus value, this is minus value, resultant force is equal to 0. Your answer is correct. The resultant force is equal to 0. This is a checking answer. Answer is checking. That is all more. This is also very important. Important. Next, one more question. Hence, the total system is in equilibrium. The total system is in equilibrium situation. That is next second. Next, the second question. This is a Q small q. This is a capital Q. This is a 4Q. Distance between two charges is R. So capital Q is equal to question mark. So that force on 4Q is 0. 4Q is 0. Now you can take like this. This Q is acting on the charge, this also Q also acting on this direction. But what is a Q value? What is a Q value? This is a positive charge, this is a positive charge, this also positive charge, this also positive charge. This positive charge will repel to this positive charge, this direction, that is a F1 force. Now, apply the Coulomb's law, F1 is equal to K into Q into 4Q. and 4q square by distance between the two charges. Distance between the two charges is 2r whole square. Now you can write F1 is equal to 4 k 4 q square by 4r square. 4r. Now next, this is two charges. This positive charge will repel to this charge this direction, that is a F1 F2 force. F2 is equal to K into Q and 4 into, sorry, K into Q, and this is a 4Q by distance between the two charges is R square, that is a F2 is equal to K 4 small q capital Q by R square, that is a F2 force. F2 force. Next, two forces are same direction. Two forces are same direction means resultant force is equal to F1 plus F2. Both are same direction. Resultant force is acting on 4Q is equal to 0. And I am taking resultant force is I am taking 0, F1 plus F2. Now F1 take this side, minus F1 is equal to F2. F1 means what is F1? Minus K 4Q squared by 4R square is equal to F2 means K 4 small q by capital Q by R square. R square cancel each other. And this is a 4 cancel, K cancel each other. Next, 1Q there, here Q cancel each other. Now minus Q by 4 is equal to capital Q. Your capital Q value is this one, and 4Q is 0. And the force is acting. Force is acting on 4Q is equal to 0. That resultant force is 0. Your answer is Q is equal to minus Q by 4. This is your answer. Now, this is a Q is instead of minus Q by 4 means the whole system is in equilibrium position. Now we have to check it. Resultant force, checking the answer. Now resultant force is equal to F1 plus F2. Now resultant force is equal to F1 plus F2. F1 means K 4Q squared by 4R square plus F2 means K 4Q plus by R square. Now we'll see. F1 is equal to, this is a capital Q. First, this is a K 4Q squared by 4R squared plus K, and next capital Q in this place I'm going to write 4 small q by R square. Capital Q is replaced by the minus Q by 4. Now I'm writing resultant force is equal to K 4Q squared by 4R squared plus into minus K 4Q into Q squared by 4R squared. This is a minus value, this is a plus value. Resultant force is equal to 0. This resultant force is acting on Q. Hence the system is, hence the total system is in equilibrium. Now that is your answer. Now next question. Question number next. Next, so what is the value of capital Q so that the force acting on small q is equal to 0. Small q is equal to 0. Now we'll see above figure, same above question. This is a q, capital Q, 4q. Distance between the two charges is r. Now we'll see. So what is the value of q so that the force is acting on small q's? Where is a small q? This is a small q. So force is acting on small q. Now like this. So what will happen in this situation? In this situation, you see carefully. Come to the point. So first of all, this is a force, this is a 4q, this is a q. This why I'm taking, you see the what is the value of q, so that force is acting on q and total force is acting on q, and this 4q is acting on the charge, this q, capital Q is acting on this charge. The resultant force I'm going to find out. Now this 4q is a positive charge. This positive charge will repel to the charges this direction, that is a F1 force. Now F1 force is equal to K into 4q into q by distance between the two charges is this one. F1 is equal to K into 4q squared by 4r squared. Now your value F1 value. Now next, this is a positive charge. This positive charge will repel to this positive charges this direction, that is a F2 force. Now F2 force is equal to K into q, capital Q small q by distance between the two charges is r squared. Now F1 F2 are same direction. F1 F2, two forces are same direction. Now resultant force is equal to F1 plus F2. Resultant forces should be 0. Why means resultant force is acting on the q is equal to 0. That's why resultant force is equal to 0. F1 plus F2. F1 take this side minus F1 is equal to plus F2. Now you will see F1. So F1 means now you will see the K minus K 4q squared by 4r squared is equal to F2 means capital K, capital Q, small q by r square cancel each other. Now K cancel each other. 4 cancel each other. Now small, this is 1q and small q cancel each other. Now minus q is equal to and capital Q, and the capital Q is equal to minus q, your answer. But we have to check the system is in equilibrium. The system is never to be equilibrium. We have to check it. Now how can we check it and check the answer? Check it. Now you'll see the resultant force is equal to F1 plus F2. Resultant force is equal to F1 plus F2. Resultant. F1 means now I'm going to write K 4q squared by 4r squared plus F2 means K capital Q small q by r squared. So 4 cancel each other. Fr is equal to kq squared by r squared plus capital Q small q by r squared. Now Fr is equal to, now capital Q is equal to minus q. Okay, and K small q squared by r squared plus small q by r squared. Capital Q means I'm going to write minus q. Fr is equal to kq squared by r squared plus into minus kq squared by r squared. This is a plus is cancel. Resultant force is equal to 0. Resultant force is equal to 0. But check it. Now the system is equilibrium or not, we have to check it. Now we'll see what will happen. Okay. So again, I'm going to start the next point. Next question. Next question. This is charge Q, capital Q. This is 4Q. 4Q. So question is what is the value of charge be placed, so where it is located to make the system is system in equilibrium. Now we'll see in the two situations we are doing here, what is the value of the charge be placed there. So where it is located to make the system is equilibrium. Now you can take the two ways. In this situation, we have to do cases. Case number one, x is equal to d by root of q2 by q1 plus 1 plus 1. This is a like charges, q and q for q. Null point. This is a null concept. Null point. X is equal to d by distance between and d by 3 to d by 3. Distance between. Now we will see this is a distance between. Now d by 3 plus d by 3 to d by 3. Now you are getting d. Okay. And the q2 charge, this is a 4q by q1 charge q plus 1. Now you'll see this is a total value is d by root of q2 cancel. This is a root 4 plus 1. This is a x is equal to d by root 4 means that the value is root 2 square cancel. Root 4 value is equal to 2. 2 plus 1 is equal to x is equal to 2 by 3 your answer. Now next case number 1. Case number 1, I'm going to solve case number 1. The resultant force is acting on I'm taking, suppose for example, this Q is acting on the charge. Now this capital Q is also acting on this one. Resultant force 4Q is equal to 0. I'm taking. Resultant force is acting on 4Q is equal to 0. First case. Now Coulomb's inverse will apply. Now what will happen in this situation? This Q, this is a positive charge. This positive charge will repel to this 4Q charge is this direction, that is F1. F1 force is equal to K Q into 4Q by distance between two charges is D square. That is next F2. Now we will see this capital Q will repel to 4Q charges this direction, that is F2 force. Now Coulomb's inverse will apply between the two charges. Q into 4Q by distance between the two charges is at 2D by 3 whole square. Now, so F2 is equal to K into Q 4Q by 4D squared. This is 3 square means 9. I'm taking 9. Now you can write this is F2 is equal to K. This is a capital Q. This is 4Q by 4D squared by 9. 4 cancel each other. F2 is equal to K capital Q small q by D square 1 by 9. Take upside 9. This is the F2 value. Now resultant force is acting on 0. Resultant force is acting on 0. The resultant forces acting on them. Say Fr is equal to two forces are same direction. I'm taking F1 plus F2. Resultant force is acting on 4q is equal to 0. 0 F1 plus F2. F1 take this side minus F1 is equal to F2. F1 means what is the F1? K minus K small q 4q by D square is equal to K capital Q small q 9 by D square. D square cancel 4 cancel 1q cancel. Now remaining minus 4q is equal to capital Q 9. Now we are going to write this is what I want. We want to 4q. 4q means small q, and capital Q we need capital Q. Capital Q is equal to minus 4q by 9 your answer. Okay, by 9. This is a first case. This is a first case. Next, second case. We'll see the second case. Case number 2. Case number 2, what I'm checking here. Case number 2. Same forces. This is a charge Q, capital Q. This is a 4Q. Now, resultant force is acting on small q is equal to 0. Now, you can take this is a forces acting. Distance between two charges at d by 3 to d by 3. Now, resultant force is acting on this small charge. Two forces are same direction. F1, F2. F1 plus F2 is equal to resultant force. Resultant force is 0. F1 plus F2. F1 minus F2. I'm right. F1 means I'm writing F1. F1 is equal to this is a 4q. This is a 4q. This positive charge will repel to this positive charge is this direction, that is F1, and k into 4q squared by distance is d squared. D by 3 plus d by 3. D by 3 plus 2d by 3 is equal to 3d by 3 and d. That is the distance between the two charges. Now, next, this positive charge, capital Q will, this is a positive charge. This positive charge will repel to this positive charge is this direction. Both are positive charges. Q into Q, capital Q, small q, distance is d by 3 whole squared. Now, F2 is equal to K, capital Q, small q by d squared 9. I'm writing. Now, you can write F1 means minus K 4q squared by d squared is equal to F2 means capital K q small q by 9 d squared. D squared cancel, k cancel, what q cancel, 1q cancel, remaining what be there, minus 4q small q, capital Q 9, capital Q is equal to, we need a small capital Q value is equal to, what we are getting, capital Q value we need at minus 4q by 9 we're getting. This is the system is in the both are same. In first case, capital Q is equal to minus 4q by 9. In the second case, Q is equal to minus 4q by 9. Now we'll see resultant force is acting on 4q. You're getting answer is minus 4q by 9. Resultant force is acting on small q. You're getting answer is capital Q is equal to minus 4q by 9. The system is in equilibrium. That is your answer. Now we'll see the next question. Uniform ring and point charge. Uniform ring and point charge. Point charge. Uniform ring and point charge. Now I'm taking to the This is a uniform ring. Now this is axis, x-axis. So charge is positive charge is distributed along the ring, uniformly distributed along the ring. Positive charge is uniformly distributed along the ring, along the ring. Now this is axis, x-axis. Now positive charge. This is a point charge. This is a point charge. This is a ring. Ring having the charge is total charge is capital Q. Capital Q. Total charge. This is a small charge. The charge is placed on the axis. This is a point charge. This point charge, keeps on axis, x-axis. Positive point charge keeps on x-axis. Now I'm taking to this. This is a small element. Small element. This is a dx. This a dx having. This a dx having. This a dx having charge is a small dq. Small dq. And the distance between here to here is. I'm taking. This is odd distance. This is a small charge. This ring having total charge is Q. The ring having total charge is capital Q. But this is a small element. Small element means small element having small charge. This is a small charge. This is a point charge. And what is the force between the two charges? That is dF force. This small charge is positive charge. This also dq is a small charge, but it's a positive charge. This is a point charge. Point charge is a positive. This positive charge will repel to this positive charge is this direction. That force is a dF force. That is a small force. Small force. This is I'm taking making angle theta. Now this is axis y-axis. This is x-axis. This is a y dash. This is a x. This is a x dash. Now you can take. This is a angle theta means here opposite angle also theta. Now df can be resolved into two components. This is a x-axis. This is y dash. df is in a plane. This df can be resolved into two components. One is making angle theta means this is a df cos theta. This is a df cos theta means opposite side is this is a line. This line is parallel to this one means this is a df sin theta. Df sin theta. Now you can take the opposite side also. This is a small element dx. This small element having dq. From here to here is distance is I'm taking this is r. And now this is a dq, this is a small q, and repels this direction also df, and making angle theta here also. This is opposite side angle, and now this components resolved into two components, df sin theta and df cos theta along the x-axis, x-axis. df cos theta, df sin theta, both are in opposite direction, cancel each other. Both are equal and opposite direction. Both are cancel each other. Both are cancel each other. Components. Now, up to the Coulomb's inverse square law. So df is equal to 1 by 4 pi epsilon naught k 1 by 4 pi epsilon naught dq and q by distance is r square. That is your force. Now I'm taking only one component. I'm taking df is equal to df cos theta. I'm taking. Now we have the two components along this direction, but I'm taking the one component. Now integration applies both sides of the equation. Integration derivative cancel, and f is equal to integration df cos theta. F is equal to df means 1 by 4 pi epsilon naught and dq small q by r square. This is a cos theta. Now this is a radius of the circle. Radius of the circle is capital Q, capital R, capital R, capital R. Now F is equal to, take out constant 1 by 4 pi epsilon naught is constant, and dq, okay, uh, keep the points 1 by 4 pi epsilon naught dq small cube by r square, and cos theta. Cos theta means this is adjacent side, this is a hypotenuse. Adjacent side is ex, hypotenuse is smaller. Smaller. Now F is equal to constant, take out 1 by 4 pi epsilon naught and r square into r cube, and this is a small q x, take out integration capital D. This is integration dq means we are getting total charge. Total charge. What is the total charge? Capital Q. F is equal to 1 by 4 pi epsilon naught qx by r cube. This value is capital Q. Capital Q. Now we are getting F is equal to 1 by 4 pi epsilon naught capital Q small q x by r cube. Your answer. Now your answer. According to Pythagoras laws, this is a 90 degrees. This is according to Pythagoras laws. According to Pythagoras laws, this is a radius r, this is ex, this is small r, making angle theta. Here 90 degrees. Now Pythagoras laws applies here. What we are getting, r square is equal to capital R square plus small x square. Square take this side, small r is equal to root of r square plus x square. Now you can take F is equal to 1 by 4 pi epsilon naught capital Q small q by x. R means you can write r square plus x square. Square means 1 by 2. Already here cube there. You can write this is a force between the total charge and point charge. This is a point charge. Now x is equal to 0 means force is equal to 0 at. This is a answer. Now this is a derivation. This is a very important IP and competitive. IP 4 marks. Very important. Now today class is over. Tomorrow I will continue next topic. Okay, we will see. This is a uniform ring and point charge.